In this lesson, the target states, I can find the measures of angles in polygons. And polygons are made up of straight lines. 3 or more straight lines form the simplest type of polygon called a triangle. It's a polygon when you have a space that's enclosed inside those straight lines. So a circle is not a polygon. One line does not form a polygon because you need 3 or more lines to create that enclosed space. So a triangle is the most basic type of polygon. A rectangle is another type of polygon. It has all right angles. And a square is another type of polygon that has all right angles and also all equal sides. So all sides are the same length. Let's start with the simplest type of polygon, a triangle. If you have a chance to do this in class, this would be helpful. But if you have a triangle on paper and you were to cut off 2 of the corners and bring them up and put it together with that third angle, all 3 angles together, combined, form a straight angle, or a 180-degree angle. So the triangle sum rule states that the sum of the measures of the angles in a triangle equal 180 degrees. So in other words, if I have this triangle here, and I add up angle 1, 2, and 3, it will equal 180 degrees. The sum of all 3 angles in a triangle equals 180 degrees. And that's a helpful leaping point to help us understand the total sum of all the angles in all polygons. The triangle sum rule can also be helpful in solving problems similar to this one. Remembering that the sum of the angles in a triangle is 180 degrees can help us find unknown angle measurements in a triangle. So this triangle has 3 angles, and one of the angle measurements is missing. So I can use the triangle sum rule to write an equation that I can solve to find the missing angle, or x in the equation. 25 plus 37 is 62, 47, 57 plus 5, 62. So x plus 62 equals 180. So x equals 180 minus 62. Which is 118. So x equals 118 degrees. We can also use the triangle sum rule to find the number of degrees in the angles in any polygon. The sum of the angle measures in any 4-sided figure can be found by dividing the figure into 2 triangles. You can divide the figure by drawing a diagonal. A diagonal is a line segment that connects 2 non-adjacent vertices of a polygon. A vertex is an angle, so it connects 2 angles in the polygon that are not adjacent or next to each other. Since the sum of the angle measures in each triangle is 180 degrees, the sum of the angle measures in a 4-sided figure is 2 times 180, or 360 degrees. So in this figure you can see it is a 4-sided polygon, known as a quadrilateral. I can draw one diagonal, and only one, connecting those 2 vertices. So diagonals are lines that don't cross each other. So I couldn't draw another diagonal from here to here because I'd be crossing over that original diagonal. So there's my one diagonal that creates 2 triangles. And each triangle has 3 angles, and the sum of those angles would be 180 degrees. When I add that up, I get 360 degrees. So the sum of a quadrilateral's angles is 360 degrees. This is the sum of angles of a quadrilateral. So it's another rule. The 4 angles in a quadrilateral add up to 360 degrees. So you can draw diagonals in any polygon to determine how many degrees are in all the angles of a polygon. So here's a 7-sided polygon. It's a polygon with 7 sides. And if you were to draw diagonals in it, connecting vertices, I notice you create with those 4 diagonals 1, 2, 3, 4, 5 separate triangles. So there are 5 triangles, and each triangle has 180 degrees in all its angles. So there would be 900 degrees in this 7-sided polygon. It's called a heptagon. So the diagonals I can draw below in this polygon is 1, 2, 3, 4, 5, 6 sides. It's a 6-sided polygon. We'll have less degrees than the heptagon. So how many diagonals can I draw? 1, 2, 3 diagonals, creating 1, 2, 3, 4 triangles. So it would be 180 degrees times 4, which is going to be 720. So there's 720 degrees in this polygon. Okay, now it's your turn to try. Click pause and solve these problems in your notebook. Click play to check your answers. For numbers 1 and 2, find the missing angle in the triangles using the triangle sum rule. For number 3 and 4, use what you know about the angles in a quadrilateral to find the missing angles. If you need to, look back on your notes. For number 5, try to find out how many degrees are in all the angles of this polygon using diagonals. Good luck. Okay, here we go. For number 1, all 3 angles in this triangle should add up to 180 degrees. So if I add up the 2 angles I have, I get 103. So the difference between 180 and 103 is 73 degrees. Oops, 77 degrees. So x equals 77 degrees for number 1. For number 2, 40 plus 30 is 70, and the difference between 180 and 70 is 110. So number 2, x equals 110 degrees. And I can see that's true because I can see this angle is greater than 90. So that makes sense. For number 3, the 4 angles in each of these quadrilaterals needs to add up to 360. So I have 2 90-degree angles. And I have 127 degrees and x. So 90 and 90 make 180. And if I add that to 127, I get 307. So the difference between the total of all the angle measurements and 307 is 360 minus 307. So if I do the math, I get 53 degrees. So x equals 53 degrees. For number 4, I have 4 angles. None of them are right angles. So I have to add up the angle measurements I have and find the difference between that and 360. 15 plus 5 is 20, carry the 2. This is 15, carry the 1. So these 3 angles add up to 250 degrees. All 4 of the angles should add up to 360 degrees. So if I find the difference between 360 and 250, I get 110 degrees. So x equals 110 degrees. Okay, lastly, number 5. Well, how many sides are on this? 1, 2, 3, 4, 5. It's a 5-sided polygon that is made up of, if I draw diagonals, 3 triangles. So how many degrees are in all the angles of this 5-sided polygon? Well, it's made up of 3 triangles, so if I do 180 times 3, 3 times 1 is 3, plus 2 is 5, I get 540. So for this polygon, there would be a total of 540 degrees in all of its angles.